So, good evening, my dear students, my dear good students. You are very, very good students. I keep best students in my list. Students, I work hard for you. You have seen it. These video lectures are almost free for the children, let me tell you. Considering the expenses and hours which take to make lessons, students, I am putting hard work for students. Ultimately, these will be available free for all the students. Therefore, I always say that it is important that you will share our lectures with more and more children and
Yes, sir.
they can take benefit out of this course. And I know those students who are working regularly, students continuously, constantly, and are not wasting their time, they are the ones who will succeed. We are aware of the secrets of the success students. So those there are two type of students. Bulk is that who are wasting their time. They will be nowhere in the exam. And there is a percentage which does not waste time and use it for the best, improve their skills, subjects. They are the people, they are the children who will succeed. Is there any doubt about that? Tell
No,
me.
sir.
Okay. So I am happy that you are such a brilliant student and brilliance doesn't work till you work hard. That is very important. Determination it must be strong. Students, in order to score full marks in the examinations, and it is possible, one can always do it. So, my best wishes to all the students who
Thank you,
are
sir.
working hard, and I know they will get full marks. There's no problem. No problem. Students, whatever may be the circumstances, whatever may be the conditions, we will not give up. We will not surrender to the any crisis or any corona or anything. We will fight back. That is our determination. So students, I talked a very important lecture was given last time. Student, we have started with solid state.
Yes, sir.
Okay, now as we said, students, here there are so many important things. Why do we want to study solid, students? Because solids have got certain characteristics, certain properties, and the properties of the solids depends on what factors, students. Why the different solids have different properties? What is your answer, students? Why different solids have different properties?
Sir, different solids have different properties because of the difference in the nature of the constituent particles and the binding forces.
Okay, the structure is different, the particles are different. Absolutely correct answer. So we have started understanding, student, as I say that chemistry be taken as a science subject, students. So what we are learning, what we are teaching you, science of chemistry, how we want to see what is the story. So when we will have knowledge of the structures of the crystal, students, what particles are there, how they are arranged, what type of forces are there between these particles, and what type of crystal structures they have, then we can make students and improve the nature of the solids and their properties. And the result is that you will need solids of different properties. If you know that the satellites which are leaving from the earth to some other see planets, they will need to have very specialized type of property, students, because what type of temperature or pressure or what type of conditions they will be meeting, all this we will be needing solids. And what type of conducting properties you want, what type of thermal properties you need, students. That is whole game of the solid state. Therefore, in this course, we have not very advanced, studies, as you will see in physics, solid state, or in other higher BSc and other where they will use some tools like X-ray, crystallography, and others. We are not going into that, but basic things we will learn here. That's the point, students. The basic chemistry of the solids, fundamentals of the
Okay.
solid will be clear to us. So what we told you, student, that solids are having strong back, closely backing intermolecular forces are strong, student, and the constituent particles are almost fixed and vibrating around their mean position, students. And to just give a small recap, student, we talked about two types of solid, amorphous and
and crystalline.
crystalline. What is an isotropy, student? Is important question. What is an isotropy?
An isotropy is a phenomena in which some of their physical properties like electrical resistance or refractive index have different values along different directions.
So there was a question, objective type is glass, student, isotropic or anisotropic?
Glass is isotropic,
Isotropic. Why? Because glass is
amorphous.
amorphous solid. Student, I thank you very much. You understand what we said, student. So I give you full marks for that, student, and I motivate you. Yes, the revision is very essential, and student recap is very good. Warm up exercises we always do with the students, and students also do warm up exercises with me. As a coach, I have to be motivated all the time, students. I talk very clear to my students. I'm very open, clear. I mean, my students are part of my life. Yes, no issue, no problem. Everything is open. Have come and have a cup of tea with me. No problem, students. You are our assets and you are our family members. So that is my point with my students. We will discuss anything, everything with you. No issue. Okay. So
Yes,
don't
sir.
worry. And we have, want to help you till the last stage of your life. It is not that after my course is over, we are over. We are not over. We are continuing our relationship with students throughout our life. Wherever you go, whatever you are, and we will be with you. So we have discussed, student, distinction between amorphous and crystalline solid. Can you give me two important distinction between amorphous and crystalline solid? This question has been asked in the paper. Whatever questions I discuss, student, they are asked, have been repeatedly been asked. So no issue. One mark questions are there. So what are the two distinction between crystalline and amorphous solid, students? If you have to answer the question, what is the most
Sir,
important
crystalline solids are long range order and amorphous have short range order.
of the constituent particles?
Yes, sir.
Okay. And what else you find?
Sir, one is this. Other could be this anisotropic and isotropic crystalline solids are anisotropic in nature.
Okay.
Amorphous as isotropic.
Lot of questions are asked on isotropic and anisotropic. You know about it.
Yes, sir.
That is why we try to repeat certain revise things for you that you, yes, 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 you are aware of this. Why glass is considered a supercooled liquid, students?
Sir, glass is an amorphous solid. It does not have a fixed shape and it is a very viscous liquid because it can flow, though very slowly it can flow. For example, in old buildings, we observe that in the window panes, the upper portion is thinner and the lower portion is thicker. This is due to this property of glass.
All right, what I'm trying to tell you, students, if certain questions are put up to you, you don't have to write too much nowadays. You know it. Mostly will be objective, assertive, but informative like questions, students. And you have to take a decision out of the four, which is the right choice, or your answers are usually in one word or one line. Therefore, try to write the specific thing. Don't need to say everything about anything. Okay? The reason
Yes,
I
sir.
ask you questions is because I know students have a tendency to write unnecessarily. Don't do that. Clear? Write
Okay, sir.
less and correct. That's all. As per the points, student answer should be specific. Question is specific, answer should be specific. These are some of the ways you can score high marks in the competitions also, students. There is nothing beyond one word or I mean one line answer. Most of the time you will see that in the paper also. Okay? Numericals will have steps which you will have to write. Further, we said you have classified, student, the type of solids. We told you, student, atomic, molecular, ionic, covalent type of solid,
Yes, sir.
students. You know which is the hardest substance, student. Diamond is the hardest substance. Why?
Diamond.
Because Why the diamond is the hardest substance? What is the reason, students? Diamond is the hardest substance, has a highest melting point. What do you find, students? What happens in the case of diamond? What type of crystal is it?
It is a covalent crystal.
Covalent network solid, student. Those solids which are covalent in network, student, the bonds are very strong and then high energy will be required to break these bonds. So these bonds are also directional and you will see that they are hard. Such solids are hard and brittle, students, and their melting points are extremely high. ठीक है? And they may even decompose before melting. Are they conductors or insulators, students? Covalent compounds.
Sir, covalent compounds are insulators.
Any exception? Is there
Yes,
any
sir,
exception?
graphite. Graphite.
Graphite is an exception. ठीक है?
Yes, sir.
Students, wherever you see certain important properties of these student, and as you can see that here we are showing you certain pictures, student, the ionic crystals have got ions like sodium chloride is an ionic crystal, as we have given example. There is a sodium ion and chloride ion, student. In the crystal you can see one sodium ion. The sodium ion is smaller in size, is a cation, and this is an ion, student, and they are occupying definite positions as we have shown. What it is, we are going to tell you more information about the lattices today. See, one ion is surrounded by more than how many? Six chloride ion, one
Six
six
chloride.
chloride ion is surrounded by six sodium ion, as you can see. So here are the ionic crystals and the forces are very strong, electrostatic and ionic. So will the NaCl conduct electricity in the solid state?
No, sir.
No, sir. And if you put NaCl in water, student, will it conduct?
Yes, sir.
But when if you take NaCl and put it in water, dissolve it, if you put your finger, do you get a current?
No, sir.
No, sir. Why? You are saying that there are free ions now, they are moving. Then what is the story? What happens? Why you don't experience? There are ions in the solution.
Yes, sir.
Then what happens? There is still no electric current. What is the basic thing? What happens? You have never thought about it. I am talking of science of chemistry, student, science of chemistry. Because anything I experience, observe, I want to understand. That is my point. That's all. You have put sodium chloride in water. You are saying it is all ions inside the solution. And you are saying ions are having charges, so they will conduct. And but you put your finger, nothing. You don't experience anything. You are drinking that also. So what happens, student? Then what is the condition for it to be?
Sir, we have to provide, we have to electrolyze it. We have to pass electricity.
You have to
Then
pass
only it will
electricity.
conduct.
Or in other words, what is happening? The student, actually, what is happening? In the solution there is a motion, there is a movement of sodium and chloride ions. The sodium ion and chloride, they are moving equally in all the directions. So there is no net movement of sodium ion in a particular direction. They are scattered completely randomly all over. And therefore, student, we have to maintain a potential difference. That is what you are saying. So when you will apply a potential difference, what will happen, student? Then there will be a flow of the ions in one particular direction, student. Sodium ion will move towards one direction, chloride will move to the other direction. Then you will see the conduction. Is it right?
Yes, sir.
That's how I can think about it. You have anything else you can tell me? Anything we observe, student. I mean, experience in our life, we can try to reason out using science.
Okay.
That's our objective. Clear? So
Yes,
it
sir.
gives us a scientific attitude and scientific thinking. Chemistry to be taken as science subject, student. So then we learn it more. Okay. Thank you very much. Thank you very much, students. I keep the energy levels high with my students. Now, formation of covalent crystal. You see that when covalent bonds give giant molecule, student, this is very important. Here I have shown that, see the diamond, carbon, how many? Four bonds, covalent bonds.
4 bonds.
And giant molecules are big molecules, student. They will need a lot of energy to break them. That's why very high melting point and brittle, student. When atoms join together by covalent bonds and as a result separate layers are formed. This is the structure of diamond. You know, this is diamond,
Yes, sir.
and the other one I have shown is graphite.
Graphite.
Graphite. The pencil, lead pencils which you are using, you know that this has got layer type of structure, students. The this chapter is going to be based on imagination. Why imagination, students? Because when I'm talking of three-dimensional picture, students, of these atoms are very tiny, and three-dimensional pictures are difficult to explain to you. So you have to visualize and imagine. Visualization and imagination is another important thing in life. Visualization, student.
Okay.
Imagination, students. A lot of science works on that. You have not seen the particles like electron, proton, and neutron, and it is the imagination. But then experimental evidences come forward, and you start writing the models of the science everywhere till everything is explained. Okay, problem. Experiments will have to be done. How do I write any structure, student? I cannot write it blindly. It has to be verified by certain tools, by certain, and you already know there are machines to do that. Students, X-ray and so many other things, uh, spectrographs, X-ray machines, and so many things are there to determine the structures of these crystal, students. Okay, so change in structure makes the difference.
Yes, sir.
Graphite is conducting and diamond is not conducting, and that is because there will be free electrons which will be present in the graphite, students. And in metallic solid the story looks like this, students. Imagination, student, you got to visualize the things in your mind. Imagine. These are the positive kernels, what we call as kernel, student. And then there are free electrons, student, free electrons. Then you can see that these positive kernels are present in sea of electrons. Once the electrons are there, student, what will happen? You supply heat energy, the electrons will immediately move and carry on this. So there will be a heat conductivity, student. When there will be free electrons, they will be highly thermally conducting, student, because the heat will be immediately carried away by the electrons.
Okay.
So there one electron, so they are moving very fast, student. Their energy will increase and then becomes conducting. And similarly, here you see electrical conductivity also, students, because you have got these tiny electrons. What will happen? As soon as you will apply a potential difference, there is a positive part and a negative. Free electrons, they will move very fast, student, and there will be electrical conductivity and thermal or heat conductivity. Interesting thing, which in metallic solids, important property, metallic solids. What do you see? Thermal,
Thermal conductivity.
or what we call as a heat conductivity. Wherever you get some electrons free, students, they are very mobile, very fast movement is there. Then what will happen? They can carry the heat and they can carry the electric current also, student. Also electrical conductivity, students. So we understand this much story. Okay, good, good. Said that classify the following solid in different categories based on the intermolecular forces. Did we answer these questions last time?
Yes, sir.
Potassium sulfate, tin,
Yes, sir.
urea, ammonia. So, so we know which to classify. Silicon carbide, what type of solid is this?
Covalent.
Covalent. So rubidium, what type of solid is this?
Rubidium will be
Where the rubidium is in the periodic
Rubidium
table.
is metallic.
Metallic in the periodic table, where it is, student? Chemistry, when we start reading, everything is linked. Periodic table will come again and again. Electronic configuration will come and again to help us and answer many questions. So that is the reason we do it, student. What you see in argon, what type of forces are there, student, in the argon? It is, you will put in which category of the solid argon, students?
Uh, Argon will be covalent.
Where is covalent? Where is covalent in argon? Anything covalent in argon? There was molecular solids we studied. Molecular solid.
Okay,
These are the atomic solid, students.
molecular.
And what type of their, what do you have in argon atoms? They are monoatomic. What are they? Monoatomic, student.
Monatomic.
And what type of forces are there? Weak. What do you call them as? What forces you are going to say in the paper, students?
Weak van der Waals forces.
Only van der Waals? There are
L-
so many van der Waals forces.
London dispersion forces.
Okay, thank you very much, student. That's what I mean. See what I said to you, that there are certain words, students, that are required. That's all. You don't need to talk too much, because van der Waals forces will be there in polar also. But what is the difference in these atomic, and what type of they will have very very low melting points
Melting
and
point.
boiling point, students. The forces are very weakest in these cases. Very weak. Now let me put it, not weak, very weak. So of course they are van der Waals forces. Okay.
Yes, sir.
Okay, so far so good. All right, students. They then you are experiencing, students, such an type of the solid, students, and you have seen wherever you will get network type of solids, student, they will be hard and very high melting points are going to be there. But if certain exceptions could be there in many examples which we take, students, no problem. So polar type and non-polar type, student, all these type of solids will be there in them. Okay, so far we understand this idea also. Now, students, we are coming to important point about the crystal, students. Now, what we are saying, students, the crystal lattices. What is a lattice, student? Lattice. What do you mean by lattice, student? You are saying in a crystal there are particles. What type of particles? Constituent particle. What type of?
Constituent
There are
particle.
atoms. What type of particles you can have, student? Atoms,
Atoms, molecules,
ions,
ions.
or molecules. So there is some arrangement of this in a crystal, you are saying. They
Yes,
are
sir.
arranged. There could be one type of atom, there could be two type of atoms, but they are having some arrangement, student. Is there any arrangement of this? So what will we do then? We will use, students, if I have to give a representation of these students, if I have to represent this particle, students, then I can use points to represent the particles. But I can use the point, student. So each particle I will use a point for that. Okay? And they are, you are saying, arranged. Supposing these are the particles, students. Okay?
Yes, sir.
So what is this then? They are arranged, but there is a regular arrangement in a crystal. Regular arrangement, you can see that they are repeating. There is a regular arrangement, student. So I can say that these are the lattice points, student. This is what we mean by lattice, student. This is what we mean by lattice, that we will depict the arrangement of these particles by certain points, students, by points. So this is an example that this is one dimensional. These are the points, these are the constituent particles, student. I am representing by points, and you can see there is a regular repetition of them. So this is a lattice, student, this is a lattice. But you know the actual world, this if I have represented one dimension, this is only one dimension, ठीक है?
Yes, sir.
And if I put another, what it becomes, students? Two dimension. This is
Okay.
becoming two dimension.
Yes, sir.
One, two dimension, student. The actual world is three dimension. You know
Okay.
it. Any substance you take. So students, if the arrangement of the particle is done in three dimensional in space, I will say three dimensional arrangement of the particles, of the constituent particles in space, student, that will be crystal lattice.
Lattice.
Crystal lattice, students. Crystal lattice. Therefore, each point in a lattice is called a lattice point. Don't question could be put in any way, student, to the exam. There are assertive type and other type of statements. They will write a statement and then they will ask you something which is true, and A is true, A, B are true. Like this type of questions are coming nowadays. You know about it. So, student, each point in a lattice is called a lattice point. This is a lattice. This is a lattice.
Yes,
Then
sir.
each point is called
Lattice point.
each point. What is each point?
Lattice point.
A lattice point. Student, read it very carefully. The chapter is all imagination and visualization. Three-dimensional objects we have to visualize. It may not be possible for us to show all the pictures. Even if I show them, it may not be sufficient. And therefore, we may give you certain short tricks in this chapter for answering some questions. Short tricks, because it will not be possible to, we don't have that much time. We don't have full 1 month, I mean, to just show you all those pictures. Okay. Each point is a lattice point, student, and each point in a crystal lattice represents one constituent particle, which may be an atom, molecule, or group of atoms, or an ion. And when you will join the student lattice points by straight lines, there will be the geometry of the lattice. You can join, student. If you join this, what is happening? The points I am joining, student, you are getting some geometry of the lattice. This is two dimensional. This is two dimensional. Some
Yes, sir.
geometry you are getting.
Yes, sir.
Okay, some geometry you are getting. So when lattice points are joined by straight lines to bring out the geometry of the lattice. If we have some three-dimensional things, students,
Okay.
this is a, as I say, we visualization and practice, students. Interesting. I'm playing with it just for you people. That okay. Let me try something. What happens, students? There may be particle. Something interesting is happening. Got it?
Yes, sir.
So when I start putting three dimensional, there may be certain geometries which are coming, students. Here you are saying two-dimensional pictures are coming, square, rectangles, or whatever it is. And you may get some three-dimensional picture also, students. When we represent points in three dimension, these are the particles, students, particles of the crystal. So I hope some enjoyment is there, something is there. You see, visualization, imagination. When we work, student, then we only get answers. And you see
Okay.
a picture, it's over. And you don't have time, then it is over. We have to pay attention, student, and spend time. Then mind starts working, students. You will discover many new things. Okay? Okay. I asked in paper that unit cell. What is a unit cell, student? What is a unit cell? Now you are saying in a crystal, a big crystal can be considered to be made up of very large, tiny crystals. Very large, tiny crystals. And each, there is a definite three-dimensional arrangement of the particles in a crystal, students. So the smallest cell, smallest portion of the crystal lattice, which on repeating can generate the entire crystal, is called the unit cell.
Okay.
For example, student, for example, okay, what I'm saying, this is a wall of your home, student. Okay? Now, how you make the wall, students? By bricks,
Yes, sir.
and these bricks are your unit cells of the wall
Okay.
because they are same size,
Yes, sir.
repeated. Okay?
Yes, sir.
And the result of this is you are making a big wall. Therefore,
Okay.
students, it is three-dimensional. This is, you can put bricks on the other side also, no problem. Okay? You can put. So what we are trying to tell you, students, like this, this. Okay? So you can see that the wall is made up by the bricks, and one brick I can say it is a unit cell. It is repeating in three dimensions. It is repeating in three dimensions. Therefore, student, we define a unit cell. What is the need of the unit cell, student? Because instead of studying the entire system of wall, I will study only a unit cell. This is the smallest cell,
Okay.
okay, which is repeating, student, okay,
Okay.
in all directions, and this will create the entire lattice. So why will I study the entire lattice? I will study the unit cell. The properties of unit cell will be the properties of the entire lattice. The property of your wall are the properties of each brick. So student, it becomes whatever we try, we want to concentrate and focus so that we study the unit cell and we will study their structure, properties, and on that basis, student, we can build the entire crystal lattice. Therefore, students, the question is the unit cell, student. If I say three-dimensional students, how many parameters you will need in order to define a unit cell, student, in three directions? That is a point. The unit cell will be characterized by, student, how many parameters? Slight small amount of maths, parameters of unit cell, student, because question will be asked on this to you in the paper, students. Any paper you will go, there will be one question on that. Parameters of the unit cell, I'm saying now. How many, if I draw any three-dimensional figure, student, you can draw three, as we have shown here also, student. Any three-dimensional objects which we are drawing, students, what it has, student, what it has. Three-dimensional. If I say this is my x-axis, y-axis, student, z-axis, three axis.
Yes, sir.
So student, how many sides are there? If I say this is A, this is B, and this is C, I can choose any A, B, C, no problem. But by convention, what certain things are done which are easy. So students, there are three axes. And how many angles are there then? Tell me. How many angles will be there, student?
Three angles.
Three angles will be there, students. So student, in general, I can say that there are three sides. Three, ठीक or what we
Yes, sir.
call them three edges, students. A, B, and C, students. And then there are, students, angles between the edges. Second, there are three angles between the edges, students. So which we will be talking of alpha, beta, gamma. Okay?
Okay.
All right. Let us go to the next. Therefore, a unit cell is characterized by 6 parameters. Its dimension along three edges A, B, C. The A, B, C may not be perpendicular to each other. In a cube, they are perpendicular. You know, cube is the simplest three-dimensional cell. Which one? Cube. You know,
Cube.
cube is the simplest figure, student.
Yes,
You
sir.
know, we should practice drawing the cubes now because in this chapter, a lot of cubes will be there. Okay, I'm trying with you. If it is a cube, then you know the sides are same.
Yes, sir.
And you know the angles of the cube also. Okay? But if it is not a cube, student, it can have any lengths or it can have different angle, alpha, beta, gamma. The three angles could be different. Therefore, there will be three edges A, B, C. They may or may not be mutually perpendicular. They are perpendicular mutually in the case of a cube. And angle between the edges will be there. Now, how do we decide what angles to use, student? Here, to remember this, student, what we said, there are three edges. How many edges?
Three edges. A, B, and C.
And there are angles
Alpha, beta, gamma.
alpha, beta, gamma, students. How will we decide, student? Okay, let me put it on this side, student. Everything to be understood, student. This is my x-axis, this is my y, this is my z-axis, student. Three axis. And along the x-axis, my edge is A, student. Okay?
Yes, sir.
And along the y-axis, student, edge is B, students. Okay? Some value will be there. Some distance. Along the z-axis, student, edge is C. Okay?
Yes, sir.
How will I decide the three angles, student? I have A, B, and C, student. So if I have to decide the angle between of angle first angle student of A, ठीक है? What I will do, what I will do student, the angle which will be in facing the A student, angle which will be facing A. This is my A, ठीक है? This is my C student, ठीक है? C.
Okay.
I have drawn three. So what I will do, I will just put a hand on this. What is left? B and C.
Yes, sir.
B and C. So alpha will be the angle then between B and C. I am saying
Okay.
alpha is the angle student between B and C. ठीक है?
Yes, sir.
Here is B and C. This A in front of that. What angle is this student then? Alpha.
Okay.
Then I say beta angle student. I will cross this one B. What is left then? A and
A
C.
and C.
So beta is the angle between
C.
A and C.
C.
Where is A and C? This is B. This comes in. This is my beta angle students. Gamma angle student. I will cross this. 1, 2, 3. What is left? A and B.
Yes, sir.
So that is angle between A and B students. So which is this angle students? Gamma. So this is a way to remember students. Certain things we spend time because some confusion is there later on. Where is the angle A? Where is the angle alpha, beta and gamma? One more thing you can observe student. One more thing you can observe. Okay. What we can observe students? This this is A and in front opposite to A you have alpha. Then this is B. This is B student. Opposite to B you have beta. And this is our C student. Opposite to C you have gamma. Okay?
Gamma. Yes, sir.
This is just to practice and remember. Just see a book and just pass time. Then there is confusion. One question is coming on that. It is better to pay attention and learn and spend some time so that we don't forget the thing, student. One could have taken X, Y, Z, anyone. There are three axes, nobody stops you. But the angles then become decided. In front of the A, you will get alpha, in front of the B, beta angle, and in front of the C, you will get angle gamma. Those angles are decided by the three sides A, B, and C. Okay.
Okay.
For a cube, you will see that the edges are equal, but it not equal. Unit cell can have different A and B and C, and also the alpha beta angle may not be mutually perpendicular, students. So therefore, we know that the unit cell will be characterized by 6 parameters. Okay? How many parameters you will need? 6 parameters, students. A, B, C, alpha, beta, and gamma. And these values will change. What will be the result of that? The unit cell will change. Yes or no?
Yes, sir.
The simplest is cube, where the three are perpendicular to each other and A is equal to B is equal to C. But that's why we showed another diagram that they may not be mutually perpendicular, student. That is why we have pushed a cube, student, pushed a cube, and what it becomes. You can see the cube has been pushed, and the result of that, you can see that these values are changing. And the sides can also change. As you can see, it is a cuboid, student.
Yes, sir.
So we will land up with different types of the unit cell, students, different type of the unit cells. Okay. All right, student. So we are trying to understand everything. Okay, students. Now, students, the unit cells have been divided into two categories: primitive and centered unit cells. Primitive and centered unit cells.
Okay.
There are particle students which are present in ordered arrangement student. So in the unit cell, if I study the unit cell, I am studying the entire crystal, because the unit cell is repeated. You will be able to generate the entire crystal lattice, right or wrong.
Yes, sir.
So the oldest and the simplest was the primitive unit cell students.
Okay.
In the primitive unit cell, you can see there are particle student present only at the corner position of the unit cell. I have drawn it a cube, but you have been told that it may not be cube student, depends. The unit cell student can have different edges and different angles. So it will be decided by A, B, C values and alpha, beta.
Alpha, beta, gamma values.
We always study the simple things first, because to understand it becomes more easy for us. When students constituent particles are present only at the corner, you can see that here, this is how many are present? 1, 2, 8
Yes, sir.
particles are there, students at the corner position of a unit cell. How many corners will be there for
Eight.
three-dimensional cell like this? 8.
Eight.
So there are 8 particles, and there is no particle anywhere else here. That is called the primitive unit cell students. You will see that we have, in order to simplify, we have shown these particles like this. Actually, they are not far away from each other. They are touching each other. We will see that. Because when they are packed student, they will come very close to each other. But if I show that, then we may not be able to understand everything. That's the reason, students, we have drawn a very simplified picture of that. So this is what we have shown here, primitive unit cell student. Okay,
Yes, sir.
next we are coming to the centered unit cell students. Everything is visualization and lot of imagination in this chapter. After exam, no problem. There are short ways to remember them. We will use them. Once you get a picture in your mind, that's more than enough. So when unit cell contains one or more constituent particles present at position other than the corner students, they are called centered unit cells. Now there are particles present at the positions other than also the corners of the cube. The first one which we have shown student, body centered. Body centered BCC student. What is happening in body centered cubic cell student? Body centered cubic cell. Body centered. You can see that there are 8 particles student at the corners. Can you see them?
Yes, sir.
There are 8 particles students at the corners of the unit cell student, and one is student present, one constituent particle is present at the center of this. You can see inside the center, the body center, there is one particle at the body center student, inside it, inside it. Actually, when you will see the complete picture, they are touching, and now once it is there, these particles are touching this, opposite is touching this, but these two cannot touch if there is one at the body center. So this is called BCC, student.
Okay.
What will happen in FCC? Face centered.
Face centered.
You are having 8 particles at 8 corners, student, of the unit cell. And also, student, what do you find here? What do you find, student? One constituent at the center of each face. One constituent particle at the center of each face. You can see this is a face, student. This is the center of that face, center of that face. This is another face, center of that face, student. You can see that. This is the center. This is the center. You can see that. This is the particle at the center of this face. This is the particle. So at the center of each face, you can see, student, there are particles. This is the particle at the center of the face, student. Center of the
Okay.
face. Center of the face. How many faces are there? How many faces are there? How many
One,
faces are
two,
there,
three,
student,
4.
in a
6.
unit cell?
6.
6 faces are there, student. So you have 6 faces and the center of each face. So and the 6 faces at the center of each face you have one constituent particle. Okay? And
Yes, sir.
okay, 6 faces. Okay. Now we are coming to, students, and centered unit cell. And centered unit cell. What is an and centered unit cell, student? What do you find there? There are 8 constituent particles at the how many corners? 8
8
corners
corners.
of the unit cell. Okay? And second thing, this is, you can see that the opposite faces, student. This and these two are opposite faces and centered. And these are the two opposite faces. There are particles on the two opposite faces, nowhere else. Nowhere else, student. One constituent present at the center of any two opposite faces. One
Okay.
constituent particle present at the center of any two opposite faces, student. Any two opposite faces. How many faces are there, student?
6.
Total faces 6.
6.
And how many how many pair of opposite faces?
3 pairs.
3 pairs of opposite faces. Such will be called, student, and centered unit cells. Such will be called and centered unit cell. Any doubt till now, students?
No, sir.
Okay. Therefore, student, what I am trying to show to you, that the pictures should be very clear. We should be able to draw lot of unit cells ourselves. The simplest one I have told you, the simplest one we have told you is a cube. But alpha, beta, gamma and ABC will change, and this will result in to give Different types of the unit cell students. If there is a difficulty, student, the room in which you are sitting, you can use that for visualization.
Okay.
Your room, you can see, is a unit cell where you are sitting and studying. And you can see how many top, bottom, sides, and the wall students. And imagine these particles present at the corners, 8 corners, and the center of the faces, opposite faces. This will help us in visualizing in case of questions are put up to you. As I said, visualization and imagination will be part of this. And actually, that with the change in value of the parameters, you will get different unit cells. Yes or no?
Yes, sir.
What I am saying, students, different unit cells will be obtained, students, when what will happen, student, when the values of A, B, C, alpha, beta, gamma will change. ठीक है? As I will change them, there will be different type of unit cell, students, and 7 types of unit cells. 7 types of unit cells are possible. How many types of unit cells are possible, student? 7 types of
Okay.
unit cells are possible. Therefore, in our next class, we will discuss the 7 types and 14 Brevis lattices, and also try to see the dimensions A, B, C, alpha, beta, gamma, and try to
Okay, sir.
put up certain questions to you which have been asked in the paper based on that.
Okay, sir.
Any doubt till now, students?
No, sir.
All right, then, good night. Then I will see you in the next lecture. Keep pay attention to each and every word we are saying, because questions are not difficult. They will be asked on these small things. So we should learn each and every word, each and every line very carefully. That is always I tell to the student, don't hurry up anything. Chemistry is science. Let us learn it as a science students. All right then, good night. I will see you in the next class.
Okay. Thank you, sir.
Okay.